Hey everybody, alright, so this is my answer on the top corner. So it matches because C4H6O3. I've got 1, 2, 3, 4 carbons, 3 oxygens, and then 2, 4, 6. 6 hydrogens. So we're going to start off and you put your line on 3,000 and then 1,500. So you have a big peak at C double bond O, and then you have another peak slightly less than 3,000, so it's going to be your CH alkane. And then she did point out that thing is not a peak, so you don't really need to look at that. And then you look at your degrees of unsaturation, plug and chug this formula, and you've got 2 degrees of unsaturation. So if you look at this structure, your first degree of unsaturation is your ring, and the second one is the alkene. So 1, 2. Alright. So then you can take your structure and we're going to look at the H chart. So you have 2 types of hydrogens here. You have HA, which is next to the oxygen, and these 2 are the same, and HB, which is the other type of hydrogen. So if you look at HA and HB, HA is 4H because you have 2 hydrogens here and 2 there. 2 plus 2 is 4. And it's going to be a triplet because the neighbor of HA with a hydrogen is HB. And there's 2 hydrogens on this spot. So if you do the splitting, the n plus 1, 2 plus 1 is 3, which means you'll have a triplet right there. HB is 2H because you have 2 hydrogens on this carbon. And then if you look at the neighbors for your splitting, you have these 2 here. 2 hydrogens here, 2 hydrogens there, n plus 1. So 4 right here. 2 plus 2 is 4. 4 plus 1 is 5. So for HB, you're going to have multiples of 5. So now you match that up right here. So 4H triplet, that's HA right there. So I label that HA. HB is 2H, 2 hydrogens with multiple of 5. And there you go, right there, HB. And just to double check for a tip, we have 4 hydrogens here, 2 hydrogens there. 4 plus 2 is 6 hydrogens. And sure enough, on your formula, you've got 6 hydrogens. So everything matches up perfectly. Now I just do the same structure again because I don't want it to get too messy. I label my carbons now for the carbon 13 NMR. So I have my Ca here. I labeled it here because if you look at this, all the other oxygens are electronegative. It's literally surrounded by oxygens. So they're electronegative and they're taking away electrons from this carbon, which is de-shielding it and making the nucleus more exposed. So it's going to be farther to the left. Ca is going to be the farthest to the left because of that. So there it is. And then there's Cb. These 2 are the same. Cb, Cb. And Cb is going to be next to your oxygen. And then this is Cc, which is farthest away from everything. So because it's in a ring, it's going to be hard to differentiate Cb and Cc. So for these 2 other carbons, you can just say that they're part of the ring. That's the way Professor does it. I mean, technically, for Cb, you can say that's Cb because they're next to the oxygens. And oxygens are electronegative, but I don't think we have to get, that detailed. And then also, if you look at this, you have 3 types of carbons, Ca, Cb, and Cc. There's 3 types. And sure enough, you have 3. 1, 2, 3. Oops, sorry. 1, 2, and 3. There's 3 types of carbon. And remember that for these 2 carbons, you have C4, which means you have 4 carbons, but you only have 3 types of carbons. So remember that these 2 right here, Cb and Cb, they are the same. So it's only going to show up as 3 bars, but you actually have 4 carbons. These 2 just have the same ppm because they're the same.